Hello, and welcome to Defend the Rhino with Maths and AI. Happy Maths Week, Scotland. I'm Craig, and I love learning about maths. And my favourite subject is computing because I love playing with tech and writing code, and I can't be divided by zero. With me today is Digital Park Ranger, Daniel. Hi, Daniel.
Hi, Craig. Hi, everyone. I'm Daniel. I'm an engineer. My favorite number is 91. You think it's a prime number, but it's not. Happy Maths Week, everyone, and happy Maths Week to you, Craig.
Happy Maths Week, Daniel.
Today, we are going to be data scientists. That is a special type of mathematician, and we are going to be using data science in animal conservation.
Now, data science is a set of skills that people need to ask questions, analyse, and communicate about numbers.
We are here in our national park operations center, somewhere near South Africa, and we have a huge amount of data to deal with today. Data is information, it's things that we know. So that might be facts or figures or measurements, other things that we've counted. And we are joined by a whole network of data scientists today. That is all of you. You're joining us from all over Scotland and beyond. In fact, there are over 1,000 of you joining us live right now at the moment, answering these questions.
That's brilliant, Daniel. We're going to have a good data science team today. And we've already been asking you about times that you've been using maths this week, and you told us a few things. Someone said you used it to do some baking. Someone told us they've been using it to create a maths garden. That sounds great. Miriam and Blaze from Preston Street Primary, they've been using maths every day. And Freya from Liberton Primary was learning about BODMAS, a useful maths skill there, Daniel.
Yeah.
Luca from Ardross was doing Wild Zoo with Finfinity. And Sophie from Maynooth Educate Together was using maths to find square numbers. That's brilliant, Daniel.
Yeah. I can see here Harris has been using maths to write some stories about things that we do every day that involve maths. That's brilliant. I like that. At Bruntsfield Primary today, they have been doing Maths Week challenges and they've been looking at wild numeracy facts. I can see Ardross Primary. You've been learning about Ada Lovelace and Catherine Johnson, and you've also been doing a maths test made by HMP. And at Preston Street Primary, I can see that Isaiah and Ida, you have done an escape room for Maths Week Scotland. Oh, I'm very jealous of that. Yes.
And Ida was doing something about bugs as well. So that, again, that is very wild maths as well. It's good to see that you're using lots of different maths and data skills already this week. If you want to take part and maybe also get a shout out like those people, you can use the Menti today, which is just below me here. Then, if you answer the questions and you include your name and your school, maybe we'll give a shout out. We give a shout out, Daniel, not for the quickest answers, but for the ones that are the most insightful, the ones that are the most thoughtful as well. So maybe we'll get the chance to do that.
Yes. Okay, Craig, what are we doing today?
Well, the charity Save the Rhino says that South Africa has been the country hardest hit by illegal animal poaching. They said 1,000 rhinos are being killed every year by animal poachers. Our park ranger, Bokamozo, he's received a message that animal poachers have been seen nearby. We think that they're preparing to attack a crash of rhinos, and we think that they'll attack soon, Daniel, within the next hour, so we need to work together. Today, everyone that's taken part, all 1,000 plus of you, you're going to be our data science team. You're going to help us stop these rhino poachers. Are you up for that? You'll collect data from security cameras across the national park. Then you'll analyse that data to look for patterns of suspicious activity. Finally, you'll visualise that data to figure out where the animal poachers are so we can stop them in time.
Sounds exciting, Craig. So, are you, our data science team, ready to get started? Well, let's watch a video to find out more about our mission today.
Let's use maths to defend these rhinos, Daniel. Make sure you're on menti.com. You've entered in the code below. Daniel and I will be able to see some of your answers, your data decisions, and any questions you have. We'll be giving some shout outs too, so leave your name if you want a shout out.
Yes. We also want to see and hear how you're getting on throughout the activity today. So if you are a teacher or an adult, you can post on social media. You can use the handle at DigiSkillsEd and you can use the hashtag MathsWeekScott. We love seeing photos and messages, seeing how your classes are getting on.
Let's get started with maths and data. So, at the start of this lesson, we asked you, what is your favourite wild animal? So, we collected that data by asking you the question. Now we can analyse the results and try to understand which animals are the most popular.
Yeah, so Craig, I have the results on my screen here. I can see that there have been over 800 responses to this question. That's a
Great.
huge amount of answers. That's too many for me to just read through that list and work it out. We're going to have to visualize that data. So let's try and analyze it by putting it on a chart. So what we've got here is our data dashboard. And our data dashboard will tell us the results of this question. So we can see all the animals that you could pick from. You could say a camel, an elephant, a giraffe, a hippo, a jaguar, lion, rhino, or a zebra. Now, Craig, this is going to be a bar chart. These lines are going to get bigger the more people have said each animal. Shall we take a look?
Let's have a look. Do you want me to reveal them or are you going to do it? Oh,
Let's have a look.
Oh.
Oh.
Well, that's really clear. That's standing out right away, Daniel. I can see Jaguar is the most popular one.
Yeah.
But I can also see that there's other ones that are close. Lions are popular. The giraffe is popular too.
Yeah. And the poor hippo and the camel and even the zebra, they're a bit further behind. I mean, there's still 60 of you saying that the zebra is your favorite animal. That's still a lot of people. That's like two classrooms of pupils. But the jaguar, Craig, that's our favorite animal today.
So that was a bar chart, Daniel. We asked another question as well. So I asked, have you ever seen a rhino before? And we're going to visualize this one in a different way. Rather than just as reading it out again, let's view this one as a pie chart.
Yes. Okay.
So we can, this is just another way to visualize that data. And again, we can see the results really quickly. What's this one telling us, Daniel?
Yeah, so this one here is telling us that 71% of you have seen a rhino before at the zoo. So that's most people. About a quarter of you, 25%, 23% now, have never seen a rhino. And 6% of you have seen a rhino in the wild. Wow, that's exciting.
So being able to take data and visualize it in charts and then analyze that data and understand it, that's a really important part of maths and data science as well. Daniel, we're getting lots of responses there. I can see a lot of you liking the questions. Send it in. Keep that up. We're going to have more questions as we go through it.
Yes. Craig, Bokomozo would like to speak. Is it okay if I put him through?
Yeah, put him through.
Okay, Craig.
30 minutes until the poachers attack. Keep going.
Oh no, 30 minutes, that's not long. We'd better get going.
Yeah, so let's think about this. Now, Kruger National Park is one of the biggest national parks in Africa, and its area is 19,485 kilometres squared. To give you an idea of how big this is, from the very top north to south, it's 360 kilometres. Now, that's the same distance as between two of the schools who are taking part today. So, Noss Primary School, you're up in Wick, and St Michael's Primary in Dumfries. The distance between you and Scotland is about the size of this one national park, Daniel. It's massive.
That's huge. That's really huge. Craig, how do they keep the rhinos safe? Like, surely you can't have rangers covering Wick to Dumfries.
No.
That's a lot of people.
Well, they use technology to help them. So we want you to tell us in the Menti, what technology do you think they might be using to help keep the animals in this massive area safe? Give us your ideas and include your name and your school, and maybe we'll look at some of your answers. You're Daniel, you're right, it's a massive area. And there's no way that you could have someone who's just like walking about looking after the animals. You would never have enough people. So we need to find a way to use technology to help us.
Yeah. So, Craig, I can see a lot of people are submitting answers. Now,
Uh-huh.
remember, if you want to get a shout out, then I want to know your answer and your name and your school in the same message. So some of you are just typing in a piece of technology. I mean, that's great. That adds it to our data set. But I don't know who said that. Um, but Craig, we have got some suggestions coming
Yep.
in now. I can see here we have some people at Drumlarrig who are suggesting cameras. I think cameras
Yep.
sounds like a good tool.
Yeah, Gabby from Lonehead Primary says maybe they're using some sort of tracker. That's an interesting idea. So you could have an idea of exactly where the animals are.
Yeah.
Someone saying glass. Okay, glass might be a form of technology, but I don't think you would have a glass wall that big. You know, it wouldn't be very useful. Anna and Sophia are saying maybe wire and fences to keep the animals in, but also to keep other people out as well. That could be a good option as well.
Yeah.
Miriam saying alarms, some sort of alarm technology as well. Yeah.
Abby is suggesting an electric fence. Abby's at Ratho. Again,
Yeah.
a fence would definitely help people out, but that's going to be a huge fence to build.
Hugo is saying heat detection radars. Oh, that's very technical. Yeah,
Mm.
that might work too. And another one here, Daniel, drones. We've got a few people saying drones as well. So, what do you think about drones for monitoring this, Daniel?
Yeah, drones would let us look at lots of area at the same time and quickly get from place to place. But I guess the difficulty with drones is they need to be charged up regularly, and they also aren't really going to work if it's very windy or it's rainy.
Yeah.
So I think drones on a clear day on a smaller area would be a really good way of keeping an eye on the park.
And if you crashed it or it fell out the sky, someone would have to go and retrieve it at some point, and that might take a long time to do as well. One of the things that Hamish has said, Daniel, from Curran Primary School, and I think this is an answer that a lot of people have given, are security cameras.
Yeah, security cameras. And do you know what? Security cameras are exactly what Kruger National Park are using. They have these posts. They are big structures in the park. They are taller than humans are. And they have lots of different sensors in them. So you can see they're camouflaged, but you can see some sensors poking out. And these sensors collect data. So they collect data about the weather or light levels. They've even got motion sensors to detect animals moving around. But they've also got camera sensors. So they can take pictures, they can collect image data. We can collect these pictures and then we can analyze the pictures and try and find the poachers. So that's what we've got in the park.
Brilliant. So if we've got all these images from hundreds of cameras right across the national park, we could bring them together in our security control center and we could look at these images to try and spot an animal poacher in them. Daniel, I've downloaded the latest set of images from these cameras. Let me send you the first one.
Brilliant. Okay,
Okay,
Craig, it
that's
is
it.
transferring. It's on its way. Here we go. Right, let's have a look at picture number 1.
Okay, so here's your first image. Can you see an animal poacher in that image? Now, they will look like a person. They'll probably be carrying equipment. They might have a weapon. They're not normally in camouflage or hiding necessarily, but mm, I don't I don't see anyone, Daniel. What about you?
Yeah, why don't you tell us? Can you see a poacher in this picture? So feel free to get close to the screen, have a good look. Can you spot any people in there? Anyone that might be wanting to cause harm to one of the animals? Anyone that we might want to stop? What can you see? Is there a poacher in this picture? You can tell us on Mentimeter.
I see all your answers are coming in, Daniel. It's so much better than just having our sets of eyes. We've got the eyes of hundreds of data scientists looking at this as well. I mean, to
Yes.
me, it seems quite obvious to me. There's nothing in that picture that I can see, but it's good to have the opinions of other folk too.
Yeah. Shall we have a look and see what the data says, Craig?
Let's see what the data says.
Okay. So if we bring back our dashboard and we refresh it, here we go. Is there a poacher in this picture? Well, most of you are saying no, there's no poacher in this picture. And do you know what? I think I agree, but some of you think you've spotted something, and that's quite interesting.
Mhm. I guess what we kind of want to know is how confident are you about this as well? Because
Yeah.
it seemed a little bit split there, but to me it was pretty obvious, like there was nothing in it. But maybe those of you who thought that there wasn't a poacher in it, how confident are you from 0 to 100? Why don't we ask that question? So, how
Yes.
confident are you that there's no poacher in that image? This isn't a trick question.
No. So sometimes it's easier, rather than giving a definite yes or no answer, sometimes it's better to give a confidence, a percentage. And then that means people have an idea of how much, they should trust that number. So in statistics and maths, it's very handy. It's usually given as a probability. This is your chance. So are you 100% certain there's no poacher? Put it up to 100. Are you maybe 50-50? Maybe you put it near the middle. And if you're not confident at all, maybe you want to put it down near the 0 end.
Shall we have a look at these results, Daniel?
Yeah, why not, Craig?
Okay. So, looking at this spread, Daniel, I think some people are not confident at all. There's a spread of people who are about 50-50 sure. And then there's an even bigger number at the top who are very confident that there's no poacher in it. Daniel, this is still pretty inconclusive to me. This is, as humans looking at this, and we're not specialists at spotting animal poachers. I've never done this before. And even at that, we're sometimes making mistakes or we're thinking we're not sure about the result as well. Other times that people are using data to make predictions, they are just it is a way of predicting, of almost guessing something as well, Daniel. And it's not just for pictures that this is used.
Oh, so for example, I had a look at the weather for Lockerbie Primary. Thanks for playing along, by the way. I had a look at the weather in Lockerbie tomorrow, and my app shows showers, 80% chance of rain.
Okay, so that probably means that they have confidence that it probably will rain tomorrow at Lockerbie Primary School. Lockerbie, you can tell us tomorrow if that happens. Well, maybe not in school on Saturday, but you'll see it at the weekend. So, Daniel, maybe we have to try a slightly different approach. We took a long time there to manually look at one image. Maybe we could just skim through some of the other images. I know you've got the whole set of the images that I sent you. Let's have a look at them.
Yeah, they've just downloaded. Let's have a look. So here is our big folder of pictures. Have a scroll through some of these. Keep an eye out for poachers. If you spot a poacher in your class, I want you to shout out the word poacher. And hopefully we all spot it. So let's have a look. So keep scrolling.
Daniel, there's nothing in these images. It's just the wildlife. It's the zebras.
Yeah,
It's the
just wildlife. Oh, we've got a giraffe.
Can you
there.
go a bit faster? Go a bit faster so
yeah,
we see some
okay.
more. This is taking me ages. All right, so we've looked at 80. Let's keep
80,
looking.
okay. Let's see. No, not there.
There's a
Keep
lot of them.
going. There are a lot, but let's keep going. Hang on. Craig, there's almost 16 million pictures. And that's just from today.
Daniel, we're never going to get through these if we're just looking through them manually. At this rate, it's going to take us years. It's going to take us 2 years just to look at all these photos. We don't have that amount of time. We've only got 30 minutes.
And these cameras are taking pictures constantly. That pile's just going to keep getting bigger. There's no way.
No, there's no way that we could check all this ourselves. It's so tiring. We need to find a better way.
Yeah. Oh, Craig. Bokomozo is he's on the line. I'm just gonna patch him through.
15 minutes until the poachers attack. Hurry!
Not a lot of time. We're going to have to stop these poachers though before it's too late. So we're going to have to find a way to use technology and maths to help us. Now, we know that computers are faster than humans at doing some tasks. What if we could teach the computer to look at all of these images for us? You know, maybe it could do all the hard work.
Well, that would save us a lot of time. That would be really useful, Daniel. Then we wouldn't have to do it ourselves. The computer could do it for us and be quicker. But can we try it out on something simpler first, just to make sure it works? So, how do you teach a computer to recognize a rhino? Well, one way that you can do it is to show it lots of images of rhinos. We're going to use a technique today called machine learning. Now, machine learning is a type of AI. If we give a computer a lot of examples, it can analyze those images and it can look for patterns. It can look for things that they have in common, like shapes and colors or the objects that are in it. And the more examples that we can show it, the better, the more confident it should be at recognizing an image of a rhino. Daniel, have you got your machine learning software set up?
I have, yes, Greg. So I'm going to use this software here to train our machine. In fact, this is the same software that Google uses to train some of its AI apps. So our first step is gathering the data. This software lets me upload or capture lots of images. So we want to have lots of pictures of rhinos. Is that right, Craig?
Yeah, I want pictures of rhinos. I want
Okay.
lots of them.
Well, the good news is I have a rhino.
Oh.
There we go. Look. There
That's
is.
it.
Yep, there's a rhino.
Very high tech, Daniel. So
Yes.
we need to take some pictures of your rhino then.
Okay, so let's see. So let's take some pictures. Let's put the rhino in a few different places. Maybe the rhino's over here. Maybe the rhino's away over here.
If he's having a drink or something.
Having a drink. Yep. So maybe like there. Maybe he's having a rest.
So when you're taking all these pictures, you're basically gathering the images of what a rhino might look like. What if it was closer to the camera?
It was
Would that?
closer to the camera. Yeah. So maybe like the rhino's up here.
Yeah. I think we should definitely look out for a flying rhino.
Okay. So we've now got 41 pictures of rhinos. That's a good amount of pictures, I think. So we have collected that data. Now we're going to analyze it. So I'm going to train the model now.
So when this model is being trained with those images, Daniel, what is it doing?
Yeah, so what it's doing is it's looking for things that those pictures have in common with one another. So maybe there are certain colors or shapes or textures that are always there when there's a rhino. It's looking for things that's going to basically make a rhino different from when there was nothing there beforehand. And hopefully it should then recognize when we give it a rhino in future. So let's have a look. So I've now got the model on the right hand side now, and it's saying nothing. There's nothing in there, and it's got a confidence. So it is 98% sure there's no animal there. Do you agree, Craig?
I agree with that. There's no rhino in that picture.
Okay. What do you think is going to happen when I bring the rhino in?
I want to see. Let's have a look.
Let's see. Okay. So a rhino is entering. Oh, look at that, Craig.
So it's saying 100% confident that there is a rhino in that picture. Daniel, it's done it.
It's done it, yeah.
So look, take the rhino out.
Yep.
Bring it back in quickly. Yes, definitely a rhino. Okay. Like, try and sneak the rhino in. Try and sneak it in.
Sneak him in from the bottom.
Yeah. Oh, nothing. Rhino. Definitely a rhino.
Okay. What if the
that's
rhino's
good.
maybe like behind the trees or something? You know,
let's try that.
Let's try that. So maybe the rhino's back
Oh.
here.
Oh, that's interesting. So it's not been able to do it there, but if we move it a little bit,
If it's,
then
yeah,
it's
if
more
it's between the trees. sometimes it sees it.
So this is a problem. It's not quite working
No.
perfectly yet. We've got a question for you. How could we improve this model? How could we train the model so that it recognizes the rhino when it's behind the tree?
Yeah. What could we do differently?
So tell us, give us the exact instructions that you want us to follow. Give us your name and your school if you want a shout out. We'll give you a few seconds to do that. Some people are saying, could we zoom in? Could we zoom in maybe? That might help. Cara is suggesting put it in front of the trees so it's closer to the trees. That might help.
Mm-hmm.
Nina from Woodburn says maybe put it sideways. So again, another way that we could train this image as well.
Yeah. Do you know what?
Adam is saying from we should use AI. Machine learning is AI. That's part of what we're doing today.
Logan, who's at Lone Head, is saying take pictures of it behind the trees.
Should we try that?
I think we should try that. I think that's a really good suggestion, Logan. So let's bring up my tool again, and then we're going to add some more data to it. So let's add in my webcam again. Here we go. And you said we should train it by putting it behind the trees. So let's maybe pop him here. Take a picture. And then add some here. Maybe the rhino's, side on. There we go. Maybe the rhino's facing the other way. Okay, so we've now collected some additional data with the rhino behind the trees as well. So let's train our model again. It's going to look for more patterns in these pictures, including when it's behind the tree. And now we've got our model once again. So we bring the rhino back in again. Here we go. So last time we put it behind the trees and it said, no, there's nothing there. There's no rhino. This time.
Oh, that's much.
There's a
that's
rhino.
Much better.
Yeah,
that's good.
Yeah. We've improved our algorithm.
So what if it was a different animal, Daniel? Like, what if we brought in the jaguar or something like that? Our favorite animal. Would it think that's a rhino?
Well, luckily, I've got a jaguar here. Oh, hang on, Craig. This isn't a jaguar. This is a rhino.
No, it's definitely a jaguar.
No, the model says it's a rhino, Craig.
So what do we need to do?
Yeah, what can we do here? How can we teach it what a jaguar looks like?
I think we would just have to do the same thing again. We would have to take lots of photos of our jaguar.
Let's try it. So let's tell it we have a new animal. It's a jaguar. And then we're going to add some training data. We're going to take some images, take some photos. It says, let's take pictures of the jaguar. Maybe you could sneak over here. You could put them over this side. Maybe the jaguar has a rest. There we go. Over here.
Just
maybe
relaxing.
some shelter under the trees. Yeah. Now the jaguar might be behind the trees as well, remember?
Yeah.
So just keep collecting more data. There we are. Anywhere else you think I should put the jaguar? Collect some data, Craig?
Maybe a wee bit closer. Yeah.
Yeah, maybe something like that. Get my hand out of the way. There we are. Okay, there's a jaguar. It's got 44 images, 44 data points. So we'll train it again, including the jaguar data.
I think this is going to work. I think this is quite a good approach. So should we test it now?
Okay, so here's our jaguar. Oh, it's not a rhino anymore, Craig.
No, it's definitely a jaguar.
It's definitely a jaguar.
What happens if we swap it for a rhino? yeah, definitely
there
a
we
rhino.
go. Yeah.
And what if we put them both? It's not sure.
It's not so confident, is it?
Yeah. So this is just, but I think what we've got here, Daniel, is like the idea of it works, but we need a lot more data. We need a lot more real examples of these objects as well. And as data scientists, that's exactly what you would do as well. What you can use is you can use something called a data set. So data scientists create collections of different things that they can use for this. This is called training data. Basically, we're using data to train the machine. So in this case, what we need to find is a data set of images of rhinos. Daniel, I know that you're good at finding data sets. Do you have one in mind that we could use?
Let's have a look. Let's see. So there's a website that I use to get data sets on all the time. Let's see if it's got a Rhino data set. Let's see. Okay, Greg, what do you think of this one? So this is a website called Kaggle. It has lots of data sets on it. And there's one called African Wildlife Rhino, and it has got 752 files in it. And these are all pictures of rhinos. Different rhinos in different positions, in different backgrounds, different environments.
I think that's going to be ideal because then that gives us like a good mix of what we would expect a rhino to look like. I think we should be using that as part of our training data.
Yeah, I think this is going to work better than the toy rhino.
I found another data set that we could use, Daniel, because I think if we're looking out for poachers, we need to train the system so that it can recognize what an animal poacher looks like. Have you got this one I've just sent you over?
Yep, here it comes. Okay, so this is what you've just found, Craig.
Yeah, this is another data set that's got people in it. And it's not just got people, it's got people with weapons as well. And we really want the system, the AI system, to be able to detect if it sees someone with a weapon, because that's someone who might be putting the animals in danger. That could be one of the poachers. It's not enough just to be a person, because that could be one of our park rangers like Bokamozo, but we need to see them with a weapon as well. Do you think we could use this data set, Daniel?
I think we could definitely use this data set, Craig. I think this one would work really well. And you know, there's lots of pictures of different people with different weapons, different environments, which again, I think is going to be really good for training our machine learning model.
Okay, so why don't we make use of the powerful supercomputer in the park, Daniel, not your laptop? Can you upload our training data?
I can indeed. Okay, you ready, Craig?
Go for it.
Okay, let's upload that model now. Here we go.
So we've got that powerful machine learning model now, Daniel. Let's use that to check those 16 million images for us. Remember, we've got 16 million images to check. If we were going to do that ourselves, that would take a long time. That would take years. Let's see if we can get the machine learning model to check these images for us quicker.
Okay, Craig, I'm going to run my simulation. Here we go. This is so much quicker than us doing it. There we go, 100%. All of the images have been checked, 0 remaining. That's brilliant.
Quicker than us doing it. That was, if we'd been doing that, that would have taken us years. But using the technology, using this model, it was able to check them. You know, that
Craig,
took about
I need
30
to interrupt you. Bokamozo's he sounds really worried.
Put him on.
5 minutes until the poachers attack. Quick, tell me where to send the chopper.
okay, Bokomozo, don't worry, we're nearly there. Listen, everyone, we need to be quick. We're not quite there yet. We've got the results of our processing of those images. So now what we've got is a table with data. So what this is telling us is where it thinks it has seen our rhinos that we're trying to protect and the poachers or where a potential poacher might be. We've got two values up the top there, Daniel. The words are latitude and longitude. What do those words relate to?
Yeah, so latitude and longitude are coordinates. They are telling us where something is on the planet. So latitude tells us how far up or down we are on planet Earth, and longitude tells us how far around the planet we are. And the zero line actually, very conveniently for us in the UK, runs through Greenwich. So we're pretty much near the zero line. So these are all coordinates. These are locations in the world.
So these numbers are being used to describe locations, but we want to visualize this so that we can get a better idea of where the poachers might be and where the rhinos might be. I've asked you, what would be the best way for us to visualize location data? How might we do it? Could it be a chart? Could it be some other way of visualizing this data? This is exactly what a data scientist would need to do. They need to think about the best way to present this information to understand it.
Yes.
I can see if you're coming down now. Some people are saying using a computer. Yeah, we could definitely do that. Macy and Mertesa, I think you've got a good idea there. I might come back to that too.
Ross, good suggestion there.
Harper
Erin,
at
yeah.
Drumlandrig, maybe saying a bar chart. I don't think that'll work for this one, Harper, but good guess.
Yep, I like your idea, Tom, at Liberton. Erica, Anastasia, or at Longridge. Yep, I think that's what I'm going to do. So quite a few of you are
Perez is saying, oh, I've got a few here, Daniel. Perez is saying maybe GPS. Well, actually, GPS systems, they do use those coordinates and stuff as well. But how do they show you that on the screen? Oh, people are saying maybe using a monitor, perhaps. Okay, or an area. I think, what are you thinking, Daniel?
Yeah, I think the best tool for the job would be to use a map. So I'm going to load up a map right now. Here we go. So this is the area of interest in our park. This is where we think the poachers might be roughly. Now I can load up the rhino data layer. Here we go. So this is showing us all of the rhinos that we've got. So we can see here we've got like
these are like groups of rhinos, big groups of rhinos,
crashes of rhinos. And basically we're going to load up the poacher data layer and see if we can spot where the poachers are going and see if there's any particular rhinos that we need to get out and protect as soon as possible. So I'm going to load up the poacher data layer, and I want you on Mentimeter to tell us which rhino group is under attack so that we can tell Bokomozo where to go.
So there's nothing yet. So no answers yet. Just look carefully. Which group do you think might be under attack? I don't think it'll be every rhino. Oh, there's the poachers now, Daniel.
Oh, okay. As soon as you think you know which rhino's under attack, I want you to tell us.
Some people saying it might be April. It seems quite far from that.
Oh. Oh.
Oh, we're getting lots of responses now, Daniel.
Yes. Eric at Woodburn saying Yumatatu. Jaden Griggs at Holywell saying the same.
Dexter Antonine saying it's Umatatu. We've got loads of Umatatus coming in, Daniel, as well. Some scared faces emojis as well.
Yes. Chloe at Bruntsfield, Miriam and
Poppy
Blaze.
at McLaren, yeah.
Craig, everyone is saying the same answer here, Craig. Everyone is saying Yumatatu.
Well, that's making my confidence levels much higher. Oh, they're all coming in as Umatatu now. Daniel, tell Bokamozo now. Tell him.
Right. Okay. I'm gonna call him. Okay. 1 second, Greg. Okay, Craig. He has he's sent the message out. Let's see what happens.
You did it! I've sent the helicopter. The park rangers are on their way.
Well done. We did it. We used data and maths to figure out that the group of rhinos that is in danger is Umatatu. And we've sent a helicopter out to deal with the poachers.
Yes, well done. You had to do a lot of work to defend these rhinos. You learned about collecting data, like our favorite animals, and then we visualized that data in charts and tables. We then tried to analyze some data by hand, all of those pictures. But what we realized was it would take too long to try and analyze 16 million images manually. So what we did was we trained a machine learning model to spot patterns in those pictures, to find rhinos and poachers. And we ran that model across our whole data set of 16 million images. And lastly, what did we do? We put it on a map. We found where the poachers were, we sent out the helicopter, and Umatatu is safe.
Thank you for being part of our data science team on Maths Week Scotland. We couldn't have done it without your help. You used your math skills to help keep the rhinos safe for another day. Now, there is one last task that we need you to do, and it's important. We need you to answer some questions about today's event and tell us what you thought. Also, we're on YouTube today, so tell your teacher to smash that like button and subscribe to our channel so that you can see and take part in all our future activities. Hit that like button, Daniel.
Yes, and if you are a teacher or an adult, you can post a picture and let us know how you got on. You can use the hashtag MathsWeekScot. You can mention us at DigiSkillsEd. And if you keep watching till the very end, you're going to see a certificate just for your class. We have had a lot of fun defending these rhinos with you today.
It's been brilliant, Daniel, with all these hundreds of people taking part. Over thousands at one point, I can see.
At some point, yeah. So if you've enjoyed this activity, we have more math activities on our website. You could try out code your own data selfie, or you could try out plug in the numbers and learn about renewable energy. You can go to our website, cyberskillslive.com.
Thank you very much for joining us today. So for now, it's goodbye from Bokamozo, and it's goodbye from Daniel.
See you.
And it's goodbye from me. Bye-bye.
Bye, everyone.
Apex dropping bombs. Apex dropping bombs. Apex dropping bombs.